Hello, am I audible to all? Okay. Hello. Hello. So, good afternoon, everyone. In last lecture, we have seen the important terms related to the circuit breaker. That is the arc voltage. Okay, first is the arc voltage. Means actually what is happening when we are trying to disconnect the two contacts of the circuit breaker. That is when we are separating the moving contact from the fixed contact. That time what happens, due to the high voltages, the arc is struck between these two contacts, and we have to extinguish that arc. That is the main uh, uh, main aim in this circuit breakers. Okay. uh, so what is this arc voltage? So when that arc will be developed there, so whatever be the voltage appearing across that contacts of the circuit breaker, so that is nothing but the arc voltage. Okay, so when the arc will be developed, so whatever be the voltage across the contacts of this circuit breaker is nothing but the arc voltage. Okay, then we have seen also that this arc voltage is low. It is minimum which is required for maintaining the arc. So when we are making this current zero, means when the short circuit will happen there, so that time the current will be maximum and your voltage will be minimum, and that minimum value is nothing but the value of voltage at which the arc will be maintained there. But if we make this current zero, at that time this voltage get increased. Okay, at that time this voltage get increased to the peak value. Okay, so after that, next point we have seen is the restriking voltage. Okay, so restriking voltage is nothing but the voltage when this current zero will become. Here you can see when there is current zero, means it means that the contacts of the circuit breaker are open. Okay, the contacts of the circuit breaker are open, and current is equal to zero, and current is equal to zero. That time whatever be the voltage going to the maximum position, that is nothing but the restriking voltage. So this restriking voltage is the transient voltage appearing across the circuit breaker contacts. Okay, so when we are immediately after the opening of the breaker contacts, means when we are opening the circuit breaker contacts, so whatever be the voltage appeared across the contacts is nothing but the restriking voltage, because when these two contacts are closed, the maximum current is flowing through the circuit, right, under the fault condition also. But when you are opening these contacts, immediately your current will become low and your voltage will become high there. Okay, so that is the restriking voltage, it is also called the transient recovery voltage. So recovery voltage also we have seen here, but this restriking voltage we also call it as the transient recovery voltage, because it contains so many transients. You can see here how it is shown. Okay, there are transients, that's why it is called the transient recovery voltage. Okay, then when the current across the contact of circuit breaker is zero, and the high frequency transient voltage develops in whole breaker contact and is produced by sudden distribution of energy between the electric and magnetic field. So these high this transient or that restriking voltage is developed due to the distribution of the energy between electric and magnetic fields, and this transient voltage is called the restriking voltage. And always remember, it is at current zero instant. Remember, it is at current zero instant. Then we have seen the recovery voltage. So this recovery voltage is the normal frequency RMS voltage. Normal frequency RMS voltage that appears across the contacts of circuit breaker after final arc extinction. Okay, means when finally your arc will be extinguished, that time whatever voltage appears across the contacts is nothing but the recovery voltage. Recovery voltage. Okay, and it is approximately equal to the system voltage. So first is when current is equal to zero, means current becomes zero, that time there will be the restriking voltage, means it is the condition when at this current zero instant you are just separating the contacts of circuit breaker. Okay, you are just separating two contacts of circuit breaker. That time there will be restriking voltage, and after some time when the arc will finally extinguish, that time the voltage appeared is nothing but the recovery voltage. Okay, it is nothing but the recovery voltage. Okay, or it is approximately equal to the system voltage. Okay, so these points we have discussed in yesterday's lecture. Now today we'll see the derivation of restriking voltage, or it is the calculation of restriking voltage. Okay, so first of all we will consider some conditions. These are the ideal conditions, just like your ideal transformer. Okay, so here we are considering some conditions or some assumptions. So at the maximum restriking voltage, after the removal of fault by breaker contact opening, to calculate the restriking voltage. Okay, to calculate this restriking voltage, this current interruption is assumed to be taking place at natural current zero. Means what we are considering, that current interruption. Okay, current interruption is taking at the natural current zero. Okay, means as per the sine wave, when the current becomes zero naturally here, that is considered as, okay, so that is considered as a current interruption. Okay, then assume the whole system is lossless. Okay, means there is no any loss in the system, and the fault does not involve any arcing. Means if any fault will occur, it is not producing any arc, and effect of corona and saturation is ignored. Okay, means there is no any effect of corona and saturation. So these are the assumptions. So here we are considering one circuit. The source unit is there, inductance is there, capacitance is there, and here you are connecting one circuit breaker. Suppose there is you can consider a bus bar. Okay, and if the short circuit will happen between these two contacts, then how actually this circuit breaker is working, we'll see that, but we have to study here the derivation. Okay, now you can also consider here the resistance. Okay, you can also consider here the resistance, but here that inductance is more as compared to the resistance, so this resistance is neglected here. Okay, because the parameters for the transmission line are R, L, G and C, right? R, L, G and C. So here means as per the given we can neglect some parameters also. Okay, so here we are considering the L and C only, and the short circuit is occurred between two phases. Now here we have to write the equations one by one, everyone, and note it. Okay, so suppose what we are considering, the voltage across the circuit breaker contact will be equal to the multiplication of fault current and system impedance. Okay, so when we are considering the voltage, to find the voltage, V is equal to IR when we are considering the DC circuit, but when we are considering AC circuit, that V is equal to I into Z. Okay, there is no only resistance, but there is impedance, right? So it is equal to I into Z. So the voltage across the circuit breaker contact is nothing but the product. Okay, product of the current and the impedance. Okay, so let us assume this voltage to be V of t, and for making calculations easy, consider every parameter in Laplace domain. So we are considering all parameters in Laplace domain. All of you have studied this Laplace's equations. Okay, you studied in network. Okay, therefore, so if we are considering that I of F is the fault current, okay, I of F is the fault current flowing, then V of S is the supply voltage, V of S is the supply voltage, and Z of S is the system impedance as seen from circuit breaker contacts. Okay, so we have to consider the source side and the circuit breaker side. Okay, so this Z of S, when we are using the Laplace's equation, we have to write this. Now, just tell me before going to the next stage. So just tell me what will be the inductance, how we are writing the inductance in terms of Laplace. Yes. And suppose this Vm is the source, then how we can write this in terms of Laplace's equation? Yes, anyone? How to write this L? How to write the C in equation? Yes, anyone? Shraddha, Dipali? Yes, anyone? Yes, anyone? How to write in Laplace's equations? How to write this C? C is equal to Revati, Payal. Yes, anyone? So if the source is Vm, it is becoming Vm divided by S. How we are writing this L? L as 1 upon S L. Sorry, it is for the capacitance, not for the inductance. For inductance, it is, yes, anyone? For inductance, it is equal to only S into L. And for capacitance, it is 1 upon SC. Right? Na? Is it right? Is this right? Yes or no? Yes or no? Okay. So here, uh, now we are considering that I of is the fault current, V of S is the supply voltage, and Z of S is the system impedance, right? So V of S can be written as V is equal to IR, and here it is V is equal to I into Z. So V of S is equal to I of F into Z of S. Now, but source voltage is Vm sine omega t, right? So, source voltage is Vm sine omega t, and when we are considering the natural current is zero, okay. So, this is the source voltage Vm sine omega t, right? Na, it is equal to Vm maximum value, and when we are applying for this whole, that time we are writing this as for any AC circuit, it is written as Vm sine omega t, right? Vm sine omega t. But what we are doing, we are finding this at this restriking voltage is at current zero. Okay, current zero instant. So when this is current zero instant, that time, this voltage is the maximum. Okay, this voltage is maximum when the current when there is natural current zero, when the circuit breaker contact will open, that time there will be maximum voltage present, which is nothing but Vm, right? And this V of S is equal to Vm divided by S, we have seen. And impedance is mainly offered by inductance, means Z of S is equal to L into S, and I told you as S into L. Both are same or different? Is there any effect if I'm using SL or this? Nothing. Okay, no effect is there. Okay, so uh, uh, when we are considering the source side here, okay, means source voltage when we are considering. Now similarly we have to write equation for this the source voltage. So this from equation number one means here we have to put here now the values, means V of S is equal to V of S, the source voltage is now here. It is Vm divided by S, right? It is Vm divided by S is equal to I of I of F into Z of S, and I of F. Now current I is equal to, when we are considering the current I, so this I is equal to V divided by R. Okay, I is equal to V divided by R. So what is the that system voltage? It is equal to Vm divided by S, right? Divided by R. Now when we are considering the source side, that time that time uh, uh, only your inductance is considered, and for the inductance is represented in the Laplace's form as L into S, so it is equal to Vm divided by L S square. Okay, it is equal to Vm divided by L S square. Okay, up to this point, any doubt? इथपर्यंत समजलंय? Yes or no? समजलंय का? Any doubt if you are having? So let me know. I think no doubt. Okay. So here this I of f is equal to Vm divided by Ls square. Now, when we are considering this circuit from the circuit breaker side, okay. So just wait, I'll show you that circuit again. So here, when we are considering the source side, that time, this L inductance is in series with this source, okay. But when we are considering from this circuit breaker side, this inductance and capacitor both are connected in parallel here, okay. Both are connected in parallel. So we have to write equations for the both, just like when you are considering the equivalent resistance, okay. So if you want to find, suppose the two resistances are given which are parallel, how we are finding the equivalent resistance? R equivalent is equal to, R equivalent is equal to, yes, R equivalent is equal to, what is formula? Anyone? If two resistances are in parallel, when two resistances are given in parallel,
R2
yes,
into R1
R2 into R1,
divided by R1 plus R2.
correct. So when two resistances are given, so equation is simply R1 R2 divided by R1 plus R2. Now here what we are finding? We are finding the impedance here, okay. So the same thing is applied here. So here we are finding the equivalent impedance, which is equal to Z1 Z2 divided by Z1 plus Z2, Z1 plus Z2. Now here, this is your inductance, right? And one is your capacitance, okay. And both are in parallel here, okay. Both are parallel. So for the inductance, it is represented as L into S, or you can write it as SL, okay. And the capacitance as 1 divided by 1 divided by SC, okay. So we have to find this Z equivalent, okay. Means the total Z, or you can say this as Z of S is equal to uh, Z1 into Z2. So what is Z1 Z2? It is L into S, or you can write it as SL into 1 divided by SC, right? And divided by Z1 is SL plus 1 divided by SC. Okay. So you can check this equation. So Z of S is equal to SL. Okay. Or LC into 1 divided by CS plus LS plus 1 divided by CS. Means we are just finding there the equivalent impedance. Okay. Now just solve this and check the answer below is coming or not. Only this bracket is solved here. So solve this. And check these equations are coming. Okay, these two. बस सोफ्यावर बसा तिथं बाहेर. Okay, everyone solve this. So everyone solve. Okay, completed. Okay. So if it is not possible now, you can just note the equations and you can solve it later. Okay. So our equation is now it is equal to S upon C divided by S square plus 1 divided by LC. Okay. Uh, Now from equation number two, this V of S is equal to voltage across circuit breaker contact immediately after opening. Okay, means when the circuit breaker contacts will open. Okay, when the circuit breaker contacts will open, that time whatever be the voltage appeared, that is nothing but the V of S. That is nothing but the V of S. So it is equal to the restriking voltage because it is occurring at current zero. Okay, means when we are opening the contacts of circuit breaker, these are at current zero, and at that time the voltage is appearing across the contacts. That is nothing but the restriking voltage, or we also call it the transient recovery voltage. Okay, so uh, it is equal to, and this V of S is given by, I of F into Z of S. So this I of F can be written in terms of, again, I is equal to V divided by R. Okay, this V is equal to, this I is equal to V divided by R. So the V of S is equal to Vm divided by S, and divided by R, means from the source side your inductance is 1 upon, it is equal to S into L only. It is equal to S into L. I'll show you, just wait here. This I of F is equal to Vm divided by LS square, right? So it can be written as, so here uh, this can be written as here V Vm divided by S. Okay, Vm divided by S into it is 1 divided by S into L. Okay. So sorry, एकच मिनिट. Vm divided by पाहिजे तिथं. This I can be written as this I is equal to V divided by, it is equal to V divided by R. So this V is nothing but Vm divided by S and divided by this L into S. Okay. So we can write this as Vm divided by S into 1 divided by Ls. So it is nothing but Vm. Okay, how it is written? I think you understood now. Okay, so this term is only splitted here. Okay, so it is Vm divided by S into 1 divided by SL and this term into Zs, and this Zs is Z of S is equal to S upon C divided by S square plus 1 divided by LC. Okay, so again you can take this Vm common, and by solving we are getting this equation. Okay, so everyone note this equation, it is important, and in examination also they are asking this. So after that there is a next point we'll see. So everyone note the equations fastly. So all of you noted this point. Okay. Okay. So after that, this V of S is equal to Vm into 1 upon into bracket 1 upon S minus S divided by this term, that is S square plus 1 divided by LC. Now we are taking the inverse Laplace. That time we will get this V of t is equal to Vm into bracket 1 minus cos of omega 0 t. Okay, so this omega 0 is 1 upon root LC. Okay, and f0 we can write this as 1 divided by 2 pi root LC. Okay, so here this transient voltage. Okay, this is the uh, restriking voltage. We can also call the transient recovery voltage. So its magnitude is equal to 2 Vm here. Okay, its maximum value is 2 Vm here, and this is at an angle pi. Okay, this is at pi. Okay. So note this also. So in examination, when they will ask this derivation, you can write. Now here simply it is given omega 0 t is equal to pi, and time t is equal to pi divided by omega 0. So in the form of equation, we can write this. Okay, what completed? Okay. Now we'll see the next point, that is triple RV. So here, rate of rise of pre-striking voltage. This is triple RV, or it is nothing but the rate of rise of pre-striking voltage. Okay, so what is this? So it is the rate of increase of pre-striking voltage, and it's abbreviated by triple RV. Okay, means the restriking voltage is increasing, so its rate of rising that restriking voltage. So it is its voltage is in kV and time is in microseconds. So the triple RV is measured in kilovolt per microseconds. So here the definition many times asked in examination, explanation, state and explain these terms. That time they are asking this question. This triple RV is almost 90% question is there. And sometimes in MCQ questions also they are asking the unit of this. Okay, unit. So remember, it is measured in kilovolt per microsecond. So it is the rate of rise of restriking voltage which decides whether the arc will restrike or not. म्हणजे जर restriking voltage increase झालं तर काय होईल आणि decrease झालं तर काय होईल. Okay, so if this triple RV is greater than rate of rise of dielectric strength between the contacts, the arc will restrike. Okay, means if the dielectric strength increases, if the triple RV is greater than this dielectric strength, okay, then your the arc will restrike. Okay, yesterday we have seen that there is dielectric strength and also this restriking voltage, but when this restriking voltage will increase as compared to the rate of rise of this dielectric strength, then your arc will again restrike. Okay, the arc will restrike. However, the arc will fail to restrike if the triple RV is less than the rate of increase of dielectric strength. Okay, between the contacts of circuit breaker. Okay, means here in simple language, if this triple RV is more, if is greater than okay, or greater than this dielectric strength, okay, than this dielectric strength, that time your arc will restrike. And if this rate is less than the rate of increase or rate of rise of this dielectric strength, at that time arc will not restrike there. Okay, arc will not restrike there. Okay, so the value of this triple RV depends upon the recovery voltage and natural frequency of oscillations. म्हणजे किती लवकर तुमची आर्क एक्सटिंग्विश होते, so that recovery voltage and natural frequency of oscillations. Okay, then the next point. So all of you understood this rate of rise of restriking voltage? समजले? It is the simply restriking voltage only, but in what rate it is increasing. Okay. Then next point is the current chopping. So what is mean by this current chopping? So this current chopping is the phenomenon of current interruption before natural current zero is reached. Okay, before natural current zero is reached. So here what happens? What happens here? So suppose uh, here this is your natural current zero. Okay, this is your natural current zero, and here it is the restriking voltage. Here it is the restriking voltage. Now there is, okay, now there is recovery voltage. This is your recovery voltage. So what happens here in current chopping? In current chopping, this is your natural current 0 point. Okay, this is your natural current 0 point. But what happens here? Here that so this is current, natural current 0 instant. Here the current becomes naturally 0, but what happens before this 0 instant, before this current is becoming 0, the current interruption is there. Okay, current interruption means this current is becoming 0 before this 0 point. म्हणजे इथेच कुठेतरी काय होते, करंट 0 होते. सो बिफोर दिस करंट बिकम्स 0, नॅचरल 0 जिथे आहे त्याच्या आधीच तुमची आर्क एक्सटिंग्विश व्हायला चालू होते. म्हणजे तुमचे कॉन्टॅक्ट ब्रेक होतात किंवा किंवा करंट 0 होते. दॅट इज नथिंग बट द करंट चॉपिंग. सो this current chopping mainly occurs in air blast circuit breakers. Okay, air blast circuit breakers because they retain some extinguishing power irrespective of the magnitude of the current to be interrupted. Okay, so this current chopping is mainly occurring in air blast circuit breakers. Air blast circuit breakers means what? Suppose these are the two contacts and this is your arc, then the air will be provided, or this air blast circuit breakers are provided so that uh, so that uh, this will break the arc. Okay, or they will extinguish the arc. Okay, so that the contacts will get separated easily. That is nothing but the air blast circuit breaker. So there are different types of these air blast circuit breakers also. Okay, so the current chopping mainly occurs in air blast circuit breakers. म्हणजे नॅचरली करंट 0 यायच्या आधीच तुमचा काय झालाय, करंट 0 झालाय. ओके, सो because they retain same extinguishing power irrespective of the magnitude of current to be interrupted. म्हणजे याच्यामध्ये काय असतं, कंटिन्युअसली आपण हे देतोय, म्हणजे एअर ब्लास्ट देतो तिथे, की मग ते काही चेक करत नाही तुमचा करंट किती झालाय, तो 0 झालाय का नाही झाला, ते काही चेक करतच नाही. तुमचे आर्क एक्सटिंग्विश झाले नाही झाले, त्याच्या आधी झाले काय, म्हणजे ते काहीच चेक करत नाही. ठीक आहे. सो so this is occurring in this air blast circuit breakers. Okay, so when breaking low currents, for example transformer magnetizing current, with such breakers the powerful deionizing effect of air blast causes current to fall abruptly to 0 well before the natural current 0 is reached. Okay, so what is happening actually when we are considering the low currents? Okay, in transformer magnetizing currents, okay, for example transformer magnetizing currents, when we are considering with and when we are applying this or when we are using the air blast circuit breaker, so what will happen? Already the current is zero. Okay, already the current is zero, and we are using this air blast circuit breaker to deionize the arc. Okay, to deionize the particles between the two contacts. So that current is already less, and again it will become low or it will become zero. Okay, before the natural current zero. And this phenomenon is known as current chopping and results in production of high voltage transient across the contacts of circuit breaker. Okay, well, what is happening? When here only before this natural current is zero, when before that only when this uh, uh, current becomes zero here. So here only your voltage is increasing. Okay, here only your voltage is increasing, and that voltage is nothing but the uh, transient restriking voltage. Okay, okay. So here you can see again we are considering the same figure, that is here supply is there, inductance, capacitance of the transmission line we are considering, and suppose any fault is occurring in the bus bar, there we are connecting the circuit breaker. Okay, we are connecting circuit breakers everywhere. There are relays and circuit breakers. Okay, everywhere these are present. Okay, and circuit breakers are more than the number of relays. Okay, because at each point these are connected to disconnect the faulty section there. uh, and here the short circuit is occurring. Okay, that is a fault. Fault is occurring here. Means same diagram shown here. Now here you can see whatever I told you. Now you can see here this is the current zero, natural current zero. Okay, here natural current zero is there, but this point here the natural current 0 point. Okay, but what is occurring here? Your before that only the current becomes zero. Okay, before that only the current becomes zero. So this is the first current chop. Okay, and this is the arc current. Okay, this is arc current, and this is the first current chop, means it starts decreasing. म्हणजे पहिल्यांदा जेव्हा आर्क प्रोड्यूस होईल. ओके, सो that arc current is here. Okay, current is more there, but here you can see the current becomes less now, and at this point here the current becomes zero. Okay, the current becomes zero. Actually naturally your current should be zero here. Okay, okay, but it becomes zero before the natural current is zero. So what is given? Current finally suppress before natural current is zero. Okay, and at the same time the voltage wave is also shown. So this is your arc voltage when the arc is developed. So arc voltage is nothing but the voltage appeared across the contacts of circuit breaker uh, when there is a arc. Okay, and restriking voltage is here shown. Why it is before? Because because here the current becomes zero. Before the natural point only the current is becoming zero. Therefore, the transient recovery voltage, or we can say the restriking voltage, will be present there. Okay, and after that there will be recovery voltage, which will again go towards the system voltage. म्हणजे एखादा फॉल्ट झाल्यानंतर किंवा ती आर्क डेव्हलप झाल्यानंतर आर्क एक्सटिंग्विश होते. आर्क एक्सटिंग्विश झाल्यानंतर द सिस्टीम स्टेबल होते. सिस्टीम स्टेबल होते म्हणजेच काय, तर रिकवर होते. रिकव्हरी व्होल्टेज इज नथिंग बट the voltage which will become equal to the supply voltage only. Okay, so that is the recovery voltage, and here the voltage at which the arc restrikes again. Okay, now suppose the arc current is I when it is chopped down to zero value. When suppose here when it is chopped down here, so here the arc current is equal to I, and therefore energy stored in the inductance is, so we all know the energy stored in inductance is given by Li square. Okay, so that energy stored is Li square. So this is I square. Remember, it is Li square divided by 2. Okay, and this energy will be transferred to capacitance C, charging the latter to a prospective voltage E given by this energy will be transferred to capacitance C. So it will charge, and the prospective voltage across that capacitor is given by Li square divided by 2. It is nothing but the energy stored, and across that capacitor it is in terms of capacitor we can write this as Cv square divided by 2. Okay, Cv square divided by 2, or it is minus V is equal to I into L divided by C holds. So remember these two equations also. Okay, then the prospective voltage E is very high as compared to the dielectric strength gained by the gap, so that the breaker restrikes. So this prospective voltage is high than the dielectric strength. Okay, dielectric strength gained by the gap, so that the breaker restrike. म्हणजे आपल्याला माहिती आहे, जर ट्रिपल आर व्ही is more than the dielectric strength, then your circuit breaker will restrike. And as the deionizing force is still in action, therefore chop occurs again, but the arc current this time is smaller than the previous case. So to decrease the effect of the arc, we are also deionizing these particles. Okay, by some external means, just like the air blast. So here this as the deionizing force is still in action, म्हणजे काय करतोय आपण एअर ब्लास्ट सर्किट ब्रेकर मध्ये आपण चेकच करत नाही की ते तो करंट झिरो झालाय की नाही. बरोबर, कंटिन्युअसली एअर ब्लास्ट देतच राहतो. ओके, म्हणजे दॅट इज इन ऍक्शन. त्यामुळे काय होते, the chop occurs again, but arc current this time is smaller than the previous case. But what happens at the time of that restriking, that arc current becomes less. Okay, the arc current becomes less, and this induces a lower prospective voltage to reach arc. Okay, so some so that current is present there. So that will again induce the lower prospective voltage to reignite the arc. And in fact, the several chops may occur until a low voltage current is interrupted, which produces insufficient induced voltage to restrike across the breaker gap. Okay, म्हणजे काय होते, जोपर्यंत जोपर्यंत करंट इंटरप्ट होत नाही, जोपर्यंत आर्क एक्सटिंग्विश होत नाही, तोपर्यंत असे नंबर ऑफ chops will occur. Okay, and this will produce the insufficient induced voltage to restrike. Okay, means म्हणजे हळूहळू जसं चॉप्स वाढत जातील तसं काय होणार आहे, रिस्ट्रायकिंग व्होल्टेज डिक्रीज होणार. ओके, नाव consequently the final interruption of arc takes place and excessive voltage surges due to current chopping are prevented by shunting the contacts of circuit breaker with resistor. Okay, that is resistance switching such as reignition is likely to occur. Means such voltage surges can be reduced or can be prevented by shunting the contacts of circuit breaker with resistor. Means we are connecting one resistance here in parallel with the circuit breaker contacts. Okay, so here we completed the current chopping and triple RV. And this derivation is also important for the restriking voltage. So remember all the terms, that is first is arc voltage, restriking voltage, then rate of rise of restriking voltage, okay, and then current chopping. So these are nothing but the problems which are faced in these circuit breakers. Okay. Okay, any doubt? Any doubt? समजलंय का अश्विनी?
Yes, ma'am.
Okay. Sonal? Saurabh? Okay. So for today, we'll stop here. We'll see the remaining part in next lecture. Okay. Thank you and have a nice day.